Evaluating trig functions using reference angles.
Best of winter light version.
Yes, find the 6 trig functions of 225 degrees. Why don't we start by drawing ourselves a nice little picture?
You know, I think every time we do a trig function, we should draw a picture.
It sounds like a reasonable thing because we're talking about triangles and we don't have a triangle unless we draw a triangle. Now, where... What did I say? I don't know. Okay, remember 0 degrees is over here.
Right.
Puts 90 up here.
Right.
180.
270 on the bottom.
270. Okay, that's going to be helpful because we need to figure out where is 225. 225 is halfway between 180 and 270.
How do you know it's halfway?
Because I did some math, like there's 90 degrees between it. If you half that, that's 45. And
180 plus 45 is 225.
yeah, it just so happens that that is the case. So our angle is right here, 225-ish. And so what we're saying is that this angle to get around is 225. That's 225 degrees.
Yep.
But we're going to use reference angles, so that's not really the angle that matters.
No, it isn't. It's actually going to be how much further past the x-axis we went to get that angle.
We want to draw a triangle from the edge of our angle or somewhere on that line up to the x-axis.
Yep, that's what we want to do.
Up to or down to the x-axis.
Connect the x-axis and no other axis.
Yes. So now if this was 225 degrees to get around, we went 180 and then we went 45 more, so this is a 45-degree angle. Now, I think there's some special right triangles that
I feel like
since
you just drew the 45 in there, that yes, there are some special right triangle
things. I feel like 4590 has 1, 1, and the square root of 2 for sides.
I feel like what you're saying is correct.
Okay, but we're not in the first quadrant here. We need to definitely account for anything that might be negative.
I believe both coordinates in this case would be.
Yes, because we went left and we went down.
Yeah. Left and down, always negative.
Okay, so now that we've put those negatives in, that's why we're allowed to use reference angles, because the negatives account for the fact that we first went 180 degrees and then we went 45 more.
Yes.
So the 6 trig functions of 225 degrees.
Believe it or not, they're the same 6 trig functions as 45 degrees, but the signs are different.
Right, so we've got opposite over hypotenuse.
Which would be y over r.
Right, whichever way you want to think of it. And normally with the special right triangles, we do go ahead and look at those rationalized. So would you say that's the case?
Mathematicians everywhere typically write them like this. Although you're not incorrect with 1 over square root of 2. Those are both acceptable answers.
Cosine of 225.
This would be x over r.
X over r, so negative 1 over the square root of 2. Which is again
the exact same thing.
And that should always happen with 45, 45, 90 triangles. Tangent of 225 degrees.
Which would be y over x.
Y over x, which is negative 1 over negative 1, which means it's positive 1.
What?
Yeah.
What?
Cosecant theta. No, why did I put theta? It's 225. We totally know what it is.
I feel like you wanted to color.
Maybe. Flip sine. Flip from right here, so that should be negative square root of 2.
Yep.
Secant negative square root of 2.
Yep.
And cotangent, which we flip 1, and it's 1.
That 1's an easy flipper.
Right. And then we talked earlier in the video about all Smarties take calculus, or all students take calculus, and sure enough, our tangent was the only thing positive in the third quadrant.
Negative divided by negative, always a positive.
Tangent and cotangent. So